Today we're going to be talking about the cosine rule. The cosine rule in trigonometry is a rule that allows you to find any angle in a triangle from the three sides, or you can find the third side in a triangle from the first two sides and an angle, and those are the applications of the cosine rule. The cosine rule is given with the formula c squared, that is an awful c squared equals a squared plus b squared minus 2ab cos c. And again, this follows the ABC, which is quite nice to remember, and you get this kind of thing here, which it looks similar to the Pythagorean theorem. That's because it might be somewhat related, but then, yeah. But then there's also minus 2ab cos c, because this is applying to any triangle, not just right triangles. As you can imagine, for the Pythagorean theorem, say you had like the side A, the side B, and the angle C was 90 degrees, cosine 90 degrees, or cosine pi over 2 radians is equal to 1. I mean 0. Cosine pi over 2 radians is 0, so of course this part would cease to exist, and you're just left with the normal a squared plus b squared equals c squared. But that's just quite an interesting connection to make when you're learning about this stuff. Alright, so we are going to set out to prove that c squared is equal to a squared plus b squared minus 2ab cos c. And this is not as simple as a proof as the sine area rule, but it follows the same kind of steps at the beginning. So it should be easier to follow if you've watched the previous video. So say we have a triangle here, and the first side is going to be called A, the second side will be called B, and the final side will be called C. We know this angle, which is opposite to the side C, and we're going to label it capital C. The goal is to find C squared in order to figure out this formula here. Alright, so say you have this triangle here. The first step is going to be the same as when we were proving the sine rule. We're going to split this triangle up into a couple of right-angled triangles. So we are given this right-angled triangle here with one side A and an angle C. And we are also given this right-angled triangle here with one side being the height of the triangle and the other side being some unknown angle. But we'll figure this out later. And basically we know C is on this side, so if we can figure out this side, and we add it together and square it, we'll be able to find C. Alright, so we know A and we know this angle here, so therefore we can figure out the other two sides of this right-angled triangle. So for example, since sine is opposite over hypotenuse, and say this is our height h, sine C must be equal to opposite h over a hypotenuse a, so therefore h is a sine C. And say we have the intent to find this side here, and this is an adjacent side to the angle, so we'll use cosine. Cosine is adjacent over hypotenuse, so cosine C is equal to, I'll just make this question mark over A, and therefore question mark is A cos C. So now you know that this side is A sine C and this side is A cos C, but why did we calculate this side? We didn't have to do that in the other proof before. Well, the thing is, if we know that this segment here is A cos C, then we know that the remainder of this side with the B side is going to be B minus A cos C. So firstly, we know from the height of the triangle that this side is going to be A sine C, and we know from the other calculation we did with this side of the triangle, that this part of the final right angle triangle is going to be b minus a cos c. So let's make this clearer. We have a right angle triangle here, and we have our side c, and we have a side that is a sine c, and we have a side that is b minus a cos c. And there is a right angle here. We want to find out c squared. Well, obviously from Pythagoras' theorem, a squared plus b squared is c squared. From this theorem, we can just square this and square this to find the square of this when we add it together. So c squared is a sine c squared plus b minus a cosine c squared. So this is venturing now into the realm of algebra, basically, and you want to evaluate this down to the expression we have. And you'll find that if we expand and apply the powers in all the brackets, we get c squared is a squared sine c squared, or some mathematicians will have you write it as sine squared c. So this is actually a very useful notation that you might hear more about later when I talk about solving these equations with trigonometric functions. But yeah, so sine c in brackets squared is equivalent to sine squared c. Remember that. So it's just quite useful to know. And then plus b squared, and then because we know that a minus b squared is a squared minus 2ab plus b squared, so minus 2ab would be minus 2ab cos c and then finally plus a squared cos squared c. So plus this. And of course this can also be rewritten as cosine squared c. Like that's the kind of notation that they're going to be using with these trig functions. I'm sure there's also a thing called tangent squared c, for example. That's how they do it with these kinds of mathematical preset up functions that everyone knows about. Alright, so c squared is a squared sine c squared plus b squared minus 2ab cos c plus a squared cos c squared. Now, this looks nothing at all like our original rule. And why is this the case? Well, for one, it does not include an a squared, but it includes an extra a squared sine c squared and a squared cos c squared. But the thing is, if you look back to our original triangle over here, this triangle here, using Pythagoras' theorem, we get that a sine c squared plus a cosine c squared must be equal to a squared, because the sum of the squares of the two sides of this right-angled triangle is going to be equal to the square of the hypotenuse. So a sine c squared plus a cos c squared is a squared, and we can use this identity to take out this and this, because when you are adding them together, you are really creating a squared. So hence we have c squared is equal to a squared plus b squared minus 2ab cos c. A squared plus b squared minus 2ab cos c. Alright, so that might be harder to remember than the sine area rule, but this, unlike the sine area rule, this formula is available in the information booklet at the start of your exam. And you can use the cosine rule to do all sorts of cool things. For example, say you know a triangle has side lengths 3, 5, and 7, and you are asked to find this angle here. Or say you are doing some 3D trigonometry and you need to find the angle between two planes. So you have a plane here and a plane here, and you have this triangle here, but it's a scalene triangle, but you do know all three sides like A, B, and C. You gotta actually find the angle of this plane using the cosine rule. And the thing is, there is a fast lane to finding an angle. We know this is the way to find the third side from two angles and the side between it, but say you wanted to find the angle between two sides, and you know all three sides of the triangle, then actually we can just rearrange the cosine rule into something that is also quite difficult to memorize, but it's a useful thing too. If you are willing to memorize it, it'll speed up the process in exams by a lot, because you'll be confident and you'll go, ah yes, I need to find an angle and I can just use this thing that I remember because I understand the cosine rule and I'm able to apply it. Alright, so c squared is equal to a squared plus b squared minus 2ab cosine c. And really the test of understanding here is whether you can get this into the form to get cos c. And like, just remember that this can apply to any triangle. There's no restriction on where this applies. Alright, so if c squared is a squared plus b squared minus 2ab cos c, first we're going to try and isolate the cosine c, because this is the only term which the angle has any relevance to. So let's say first we subtract the a squared and b squared on both sides, so c squared minus a squared minus b squared is equal to minus 2ab cos c. And frankly, I do not like the negative sign here, so I'm going to multiply everything by -1, and so we get a squared plus b squared minus c squared. I just did it the fast way here, so c squared times -1 is going to be negative c squared. Then these negatives are going to become positive for the a squared and b squared, so I'm going to write them at the front so I don't have to write in negative sign at the front. But anyway, a squared plus b squared minus c squared is going to be equal to 2ab cosine c. 2ab cosine c. And so divide both sides by 2ab and you get a squared plus b squared minus c squared over 2ab is equal to cos c. And finally, you can take the inverse cosine of both sides, the cos -1, on your calculator to find the angle for c, for which a known value of cosine c is true. So c ends up being the inverse cosine of a squared plus b squared minus c squared, so a plus b minus c, over 2ab. And that is the other immensely useful application of the cosine rule. Alright, in the next video we're going to be going over the other sine rule, not the area one. There's another one. Isn't that great? And alright, so thanks for watching.